طيب بسم الله الرحمن الرحيم. طيب for Unit 6 tutorial I wanted to do the homework today, but I think some people wanted to submit before Friday or before tomorrow morning, so we'll do the homework next Sunday. I'm a bit late in posting the last homework. I'll try to do it today, so you have time until next Tuesday to submit it. We'll plan إنه we finish all the exercises before Tuesday, and then on Tuesday. That's not gonna work if someone is using the late days. We will see. The plan is to solve the last homework on Tuesday, so we don't have a class on Thursday. ولكن if someone wants to submit the homework late, then we will usually postpone the homework solution to Thursday, or I might post just the solution without discussing it, but we will see. We'll see how it goes. طيب. Okay, so we have 3 questions in Unit 6. Let's go through this together. Now, question 1. The objective in this problem is to add 2 n-bit unsigned numbers. So the size of the input is unknown. We have A consisting from A to n-1 up to A0, and number B from Bn-1 to B0, okay, to produce the output sum from Sn-1 to S0. Your task is to design a circuit that will perform serial addition of a pair of bits in each clock cycle. This process starts by adding bits A0 and B0 in the first clock cycle. In the next clock cycle, bits A1 and B1 are added, including a possible carry out from the bit position 0, and so on. Okay, so in general, this is a serial adder. Serial adders meaning so serial adder, if I have a number, just give me a minute to connect my pad. So if I have a number like 1001 plus 0011, the idea of the serial adder that the input of your circuit is going to be only 2-bit. Okay, so number A will be provided serially to your circuit, and B will be provided serially. Meaning, this is my circuit. I have 1-bit input here. This is for A, and this is for B. And I will produce the sum bits also in serial. So in the first cycle, طبعا حيكون عندي input clock input, since this is in serial, and I'm going to receive 1 bit of each number in each clock cycle. First, I will add A0 and B0 to produce S0. The addition of A0, B0 might have a carry out of 1 or a carry out of 0. So that's going to be, we're going to declare according to the state diagram, we're going to take care of these carries. And then the next cycle, I'm going to route A1 and B1. After that, I'm going to route A2, B2. And the same, I'll get S0 in the first cycle, I'll get S1 in the second cycle, S2 in the second cycle, in the third cycle, until I get to S of n-1, and here until I input A of n-1 here and B of n-1 here. Okay, so we will not create a carry ripple adder for that. Now, carry ripple adder is a combinational circuit. Here, we will do it in serial. طيب, so the following figure represents the state diagram for a more type finite state machine for this serial adder. تمام. طبعا this is the problem description. If you go to the steps of designing a finite state machine, the first will be the problem description, and from that you should be able to draw the state diagram. In this question, the state diagram is already there, so يعني your understanding of this text is irrelevant to solving the problem. ولكن anyway you should go through it to يعني make sense of the state diagram. طيب, there are four states. We have G0, G1, H0, and H1. The definition or the meaning for these states are as follow. G0 and G0 and G1 denote states where the carry in value is 0 and the sum bit will be either 0 or 1. فمعناه if I'm at G0 معناه the carry in of the step that I'm currently calculating is 0. تمام. G0 will have sum equal to 0 and carry in equal to 0. G1 will have sum equal to 1 and carry in equal to 0. H0 and H1 means that the carry in is 1. معناه H0 means the sum bit is 0 and the carry in is 1. H1 means the sum bit is 1 and the carry in is equal to 1. Okay, so let's take a look at the state diagram to see how it works. We'll take an example and then we'll start solving the problem. طيب, first when we reset, we will go into G0. G0 معناه the sum bit is 0. طبعا this is a more type machine, so the output is declared in the state itself. معناه the output only depends on the current state. It does not depend on the input. G معناه الstate G اللي هي G0, G1. This is when your carry in equal to 0. تمام. We start at G0. طيب, these two bits, 2 bits for the input, this will denote A and B that are coming in serial. So the first 2 bits are 0, 0. معناه I'm adding 0 plus 0. والcarry in كم؟ الcarry in نعرفه عن طريق الstate. If I'm at G, the carry in is 0. If I'm at H, the carry in is 1. فمعناه إنه الcarry in is 0. So what's the result of this operation? That's going to be 0 and carry out equals 0. بالتالي stay at this state. Why? عشان تعطيني السم equals 0 وتعطيني الcarry in أو الcarry out equals 0. Now if you are at this state and you get either 1 0 أو 0 1, we still have the carry in 0 لأنه we are at state G. فبالتالي what's the result of this operation? That's going to be 1 for the sum and 0 for the carry out for both cases. So if you check the state diagram, now I move from G0 to G1 on 0 1 and 1 0 اللي هي هذه. And why did I move to G1 instead of H1? طبعا G I have to move to a state which have a 1 in here. ليش؟ لأنه sum bit is 1. And then depending on the carry, I will know I'm going to move to a G state or an H state. Since the carry is 0, I have to move to the G state. So on 0 1 or 1 0, I will move to G1 and I will output S equal to 1. Okay. طيب, and so on. Let's take something with a carry. So let's say you are at a state where your carry out was 1 and the sum was 0. So let's say you are at H0 here. H0 mean the sum is 0 and carry out or carry in carry out from the previous stage is 1. معناته carry in for the next addition will be 1. تمام. Well, let's say you get 1 0 or you get 1 1. فمثلا A equal 1, B equal 1. Now carry here for the H states are 1. So now I'm adding 1 plus 1 plus 1. This will give me 1 carry 1. طيب, since sum is 1 and the carry out is 1, that means I have to move to state H1. H1 will output S equal 1, taking care of this part. And since my carry out is 1, so I'll move to an H state. Okay, and this is how you get from the description to the state diagram. Now for designing, you only need this. Even if you don't understand the description, you are only giving a state diagram with no meaning أو سواء كان له معنى أو ما له معنى, you can use that to solve or to write a code for any finite state machine. The hard part is converting any description into a state diagram. This is the most difficult part. Everything else is just systematic. You should go by all the steps, the design steps that we went through in the lecture. Okay, so let's move on. Given the above specification and assuming that a positive edge triggered flip-flop are used, what do you get from this information? You get that in your sensitivity list, you're going to use a positive edge of clock. And with a synchronous reset signal, you get two information from this line. أول شيء synchronous معناته our reset signal will not be part of our sensitivity list. The second part is that since this is a reset and not a reset N signal, معناه this reset is an active high signal. So when I go into my always block, I have to check that if reset, or I can write if reset equal to 1. This is when I reset. It's an active high signal. How did I know? From reading the signal name. If I give you the reset N signal, that means this is an active low reset. Okay. طيب, part A, obtain the state assigned table for this finite state machine, meaning I need to create the table. Let's see how I can have this part and the table. View. Let's try to write how to make the table here. I need 1, 2, 3, 4, 5, 6 columns and 6 columns and 5 rows. So insert 6 columns and 5 rows. So the first one will have the current state. Next 4 columns will be for next state given the inputs AB. So if AB equal 0, 0, if AB equal 0, 1, if AB equal 1, 0, and if AB equal 1, 1. تمام. طبعا this we should have a row on that. Let's have one row here, and so this is the next state. And this is the output. طبعا the output will not have multiple columns because it does not depend on the input. It only depends on the current state. Okay. طيب, عندي I have 4 states. So I have state G0, I have state G1, I have state H0, and I have state H1. Now, reading from the table, if I'm at G0, my current state is G0, so I look here. And if my input is 0, 0, I will stay at G0. If my input is either 0, 1 or 1, 0, I move to state G1. So G1, G1. And then 1, 1, I move to H0. The output is 0. طبعا هذا output meaning I'm talking about signal S. Okay. If you have any question in filling this table, let me know, because we're going to depend on this table in creating in solving the rest of the question. طيب, G1, if you are at G1 and you get 0, 0, you move to G0. If you are at G1 and you get 0, 1 or 1, 0, you stay at G1. So here we're going to stay at G1. And then if you get 1, 1, you move to H0. Okay, the value of S is equal to 1. At H0, if you get 0, 0, you move to G1. 0, 1 or 1, 0, you stay at H0. At 1 1 you move to H1. My output is 0 in this case. Last state, which is H1, 0 0 will get me to G1. 0 1 and 1 0 will get me to H0. And 1 1 will stay at H1. And the output is 1. Okay. Now we have the state table. Okay. Now provide the algebraic expression for the next state and the output S. Now I have 4 states, meaning I need to assign at least 2 bits for each state. So let's say that G0 is 0 0, G1 is 0 1, H0 is, I'll give it 1 1, and H1 will take 1 0. Okay, so I should change that. Oh, we should change this table to our current assignment. So G0 will be replaced with 0 0, place all. And then G1 will be 0 1. Are you following? ولا ضيعته? H0 is 1 1, place all. Just trying to make it easy. And then H1 will be 1 0. Okay, so we changed all the states from letters to our assigned values. Now we need to create the K-maps for wait, this is AB. I think I made a mistake here. And for AB00, what's the next state? And current state, I should give it some value. خلينا نسميها Y1 and Y0. This is the current state. And then I have Y1, Y0 for the next state. I need the value of the flip-flop. Oops. Okay, I need 2 flip-flops because I have 4 states, and each state will have 2 bits. طيب. Now from that I need to create a function for Y1 اللي هي Y1 plus. Let's have the current state as small y1 and y0. Next state is going to be capital Y. So I need an equation for Y1, I need an equation for Y0, and I need an equation for S. Okay, so my inputs are 4 bits. هيكون عندي the current state Y1, Y0, and I have AB for the state. I want to make it even easier to make the K-map. Let me move this one here. Wait. Oops. Shift, delete entire column. خليها فاضية ما تفرق. طيب, now I need to make the K-maps. So for a K-map, it's going to be a 4x4 K-map. Let me do it with annotation. So first, let's make the K-map for Y1. Okay, so the K-map for Y1 is going to be as follows. I have Y1, Y0, my current state, and I have AB, my inputs. It's going to be a 4x4 K-map. Okay, so I'm talking about y1. بالتالي I will read this line, this line, this line, and this line. تمام. The way I organized a state table in a way, so I can just read directly the numbers without checking the actual values. That's why I assigned 1, 1 to my H0. فبالتالي this is 0, 0, 0, 1, 1, 1, and 1, 0. And this is 0, 0, 0, 1, 1, 1, and 1, 0. So I'm just going to paste the left side number here into my K-map. So that's all zeros for Y1. Here it's going to be 0, 0, 1, 1. That's going to be all ones. And then this one is going to be 0, 0, 1, 1. Okay. I think we have to do it in 3 terms. I will take, what's the easiest way to do it? I can take this part, and I have to take this one and this one. Okay, so this will give me y1 will equal to AB, or this part is y1b. So this is y1b, or this part is going to be y1a, y1a. Okay, so that's equal to AB or y1 A or B. And then similarly, you can do a K-map for y0. So let me first write down the equation, because I need to erase the K-map. So y1 is equal to AB or y1 A or B. I need to get an equation for y0. Let's do that. So for capital Y0, I'm going to have the same K-map. But I'm going to read the value of Y0. So that's 0, 0, 1, 1. This is all ones. Here is 1, 1, 0, 0. And then last line is all ones. Okay, so I can take this line, can take this one, and I'll take this one. So y0 will equal to 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. That's y1, y0, and AB. So this line is AB bar, or this one here is y1 bar B. So that's y1 bar B, or this one is y1 A bar, y1 A bar. Can we make any modification? Don't think so. Right, so let's write the equation. Y0 is equal to AB bar or y1 bar B or y1 A bar. Now for S, we can just read it directly, I think, because S depends on the current state. So S is equal to 1 at y1 bar. So that's y1 bar y0, or this is for this part. So S is equal to 1 when y1 y0 equal to 0, 1, that's y1 bar y0, or y1 y0 bar, so that's y1 y0 bar. بالتالي this is equal to what? That's y1 XOR y0. Okay. Any questions so far? Are you guys following?
Okay.
Okay, so part B, provide the algebraic expression for next state and output. We already did that. Now draw the circuit for the serial adder. That's gonna be and this is easy to write or to draw the circuit. That's gonna be easy. Just draw two flip-flops, y0, y1, and I'll just do a general drawing and the two flip-flops. This signal is gonna be capital Y0. That's gonna be capital Y1, and then sorry, that's the other way around. So the current state is the output of the flip-flop. So this is Y1 and this is Y0. And of course you have here Y0 bar and you have here Y1 bar. Your input is capital Y1 and your input here is capital Y0. Okay, so you take Y0, you take Y1, give it an XOR. This will give you the sum bit. For Y0, you have the inputs. We have an OR gate coming from 3 AND gates here. That's going to be, this is Y0, so I'm reading this part. I have AB bar. This one is Y1B, so I take Y1 and I'll take B. And then the last one is Y1 A bar. Is it? No, this is Y1 bar. So Y1 with A bar. And then I take Y1 bar from here and I connect B to that. Do the same for Y1 and you get your circuit. And this part should be easy. Okay, so that's part C. Now part D, we write the Verilog module to implement the circuit in 3. Yeah, the one that we just draw. ولكن we saw that using this table, we can write the code much easier. So let's do that and write the code. طيب هيكون عندي module. Let's say this is finite state machine. Question 1. How many inputs do I have? I have A, I have B, I have clock, I have reset. What else? And I'll have S as the output. Okay. I have an input AB, each is 1 bit. I have an output. That's going to be an output trig. If I'm going to use it in, let it be an output. So I assign it the value later. So output S. And then I need to create rigs for Y1 and Y0. So that's rig 1 to 0 for Y and capital Y. I also have input reset and input clock. Okay, that's the first part. Second part, I would write the always block for our combinational circuit. So always at, either I get a change in the value of Y, which is the current state, or A or B. Okay. Begin. Now we're going to use case current state. Then I think there is begin and case. So case Y. Oh, I forgot something important here. I need to define parameter G0. How many bits I have? I have 2 bits, so parameter 1 to 0 اللي هي G0 equal to 2 bit of 0 0, and then G1 equal to 2 bit of 0 1, then H0 equal to 2 bit 1 1, then H1 is 2 bit of 1 0. Okay. Now in our case statement, I will check for the current state. So if the current state is G0, I have to check for the 4 cases of the input AB. So in G0, I will check for, I can do another case statement, I think. So let's do it with an if statement. So if a concatenation between AB is equal to 2 bit of 0 0, what's the value of capital Y? That's going to be G0. Then else if, I'll take this part. If AB equal to 0 1, okay, that means I'm reading this one here. Y should equal to G1. So Y will equal to G1, and you copy that. If your AB input is equal to 1 1, Y will equal to, wait, I didn't change it for this part. So if AB is equal to 1 0, that's going to also be G1, and then else Y equal to, I'm right here now, which is H0. Okay, now this whole thing is for if current state is equal to G0. You need to copy this part and check for G1. If you are at G1, you're gonna go G0, G1, G1, H0. G0, G1, G1, H0, so that's gonna be the same. And then case H0, which is here, we are doing G1, H0, H0, H1. So G1, H0, H0, and was it G1? No, G1, H0, H0, H1. Where am I? Here. So that's H1. Then last case is H1. If you are at H1, you're going to go the same. So G1, H0, H0, H1, which we already have. Okay. Now this is the end of our case, and that's going to be the end of our always block. Okay. Now what we did here is, depending on the current state, we filled the table inside our code using a case statement, and inside each current state you have either you do another case statement for AB, or انك you do it if else if, and whatever suits you. Okay, so now we're done with the first always block regarding the combinational logic circuit. Now we need to do the sequential circuit part. We will go always at, now here we're going to have positive edge of clock, and we will not have reset as part of of the sensitivity list because it's a synchronous reset. Okay. So in the combination circuit, that's going to be easy. So if reset, meaning if reset equal to 1, what do you want to do? You want to have the current state, which is y, takes on the value of what? What happens on reset?
H0.
G0. G0. If you go back to
G0,
you
yes.
find that reset is G0. So always make sure that you go to the state diagram, because if G0 is not assigned 0, 0, I mean, it might be a habit that when you reset, you just write 0. ولكن we have to make sure that this is going to the state that we want. Okay. Else, you have one thing to do, making the current state takes on the value of the next state. Okay. Why? The value of capital Y is changing in the always block that is taking care of your combinational circuit. بالتالي, this is all you need to do if you're going to follow this code, أو this coding method. The combinational part, just read it from the table, just as we did, and the sequential part, this is all you need to do. One last thing is to assign the value of طبعا for more machine, we'll assign S, which is our output, to what was it? That was so we had y1, we had y of 1 XOR y of 0. End module. Okay, now that's the code. Okay, I think this is the end of question 1. Library code to implement the circuit. Okay, so that's the code for our circuit. Okay, any questions? Everything we did was systematic approach. Practice few examples and you should not miss any questions like this in the exam. The only hard part is figuring out the state diagram. So if you have the state diagram, this question should be extremely easy for you to write. Okay, we have 8 minutes. Let's do through circuit. What's the generated sequence? We can do question 2. For question 2, the Verilog HDL code given below models the sequential circuit of a 4-bit LFSR circuit. This circuit generates a counting sequence of random numbers. Okay, first we're going to draw the circuit given by this module. So let's read. We have an input, a 4-bit input called R. We have 2 inputs, L and clock. We have an output of 4-bit Q. And then always at the positive edge of clock, if L, we're going to load the value of R in Q. That means L is the load signal. Else, we're going to apply this linear feedback shift register equation. Okay, so basically we have 4 flip-flops. These 4 flip-flops will have a positive clock. And according to the signal L, we're going to either load the value of input or we're going to apply this equation. Okay, so let's draw the circuit. Now, for this part, if you have an if statement, what's the if statement going to be in terms of hardware? What's an if statement in hardware?
A multiplexer.
Multiplexer.
Yeah, that's going to be a multiplexer. So first, let's draw the 4 registers. I have, let's do it here. 1, 2, 3, and 4. I have a common clock signal for all of them. Okay, so that's clock. Let's name this. This is Q0, Q1, Q2, and Q3. Okay, so our input, we will have a multiplexer to choose between two values. Now, the selection of this multiplexer is going to be the value or signal L. If L equal to 1, we're going to load. So assume the top line is for 0 and the bottom line is for 1. Like this, 0, 1, 0, 1. Okay, so if L equal to 1, I want to load the value of R. And R is 4 input. That means at Q0, I'll connect R0 here, R1 here, R2 here, and R3 here. Okay. If L equal to 0, I will apply this equation. Now Q will take on the value of Q3. Q3 will equal to Q3. Okay, that's the same. Q2 will equal to Q0 XORed Q3. Q1 will take Q1, and then Q0 will take Q2. Okay, so let's start with Q3. Q3 will take Q3. That means just connect Q3 to Q3. Same for Q1. So Q1 will take its own value. And then Q2, or let's do Q0 first. Q0 will take on Q2. So we take Q2 and we connect it to Q0. يبقى عندنا the input of Q2 is Q0 XORed Q3. So I'll have an XOR gate here. And I will take Q3 and Q0. Okay. طيب يبقى عندنا part 2. What's the generated counting sequence? ايش can't read. When the circuit is loaded with input 0001, and what is the period of the sequence? طيب, let's do that quickly. If I start with 0001, this is the value that I loaded into. Now the next cycle, I need to apply this equation. So Q3 and Q1 is just going to hold their value. Let's write it here, Q3, Q2, Q1, and Q0. Okay, so Q3 and Q1 is just going to be the same. And then Q0 will read Q2. So whatever I have in here, I'll just paste it in there. So that's 0. And then Q2 will take Q0 XOR Q3. So 1 XOR 0, that's going to be 1. Next cycle, these two are the same. This one will go in here, and then I'll get Q0 XOR Q3, which is 0, and paste it here. Obviously, we're done. Why? Because we started with 0001, we moved to 0100, and now back to 0001. So in state diagram, this is starting from here, going to 0100, and then back to 0001. So the next part of the question, what is the period of the sequence, is 2. Because you only have 2 states. In 2 clock cycle, your the number generated will just be these 2 states. طبعا a true random number generator should start from any number 0001 and give you all the 16 combinations, ولكن in a random fashion, يعني ما تكون بالترتيب. بس هنا once you read that Q3 is reading Q3 and Q1 is reading Q1, meaning يعني you'll not generate the whole batch of numbers. Okay, so all we did that we started with, we loaded the value 0001. We applied the equations that we had from this statement, and this is what we got. So for the period, meaning how many states for this circuit will generate to go from start to beginning. Sorry, to go from start to end. We don't have time for the last question, so we'll probably cover it at the beginning of next class. Basically, it's we need to implement a ROM, ولكن the ROM example that you have in your slides is using concurrent assign statement. And this question is asking for a procedural assignment statements. So we'll see how to do it, inshallah, next class. Any questions?